Good morning, or actually it's good evening, isn't it? I'm so tired. It's a long day. Okay, so I'm going to do 1 through 24. Maybe I'll go to 1 to 20. We'll see. I'm kind of tired. Anyway, we're going to review your final exam review sheet. And what I suggest you do is get out your little note card. You can have a 3x5 note card, front and back. Make little notes for things that I say that you need to write down so that you don't forget. Alright, these first questions that we're solving here, you're just going to follow the order of operations to get started, and then you're going to follow the algorithm for solving an equation for a variable. So first we need to distribute here and get the x and the constant out of the quantity. Alright, -4 plus 3x. Alright, next on the agenda now is to follow the algorithm. So I always like to draw a line between my left and right of the equation so I can focus on one side at a time. We need to simplify this. We have two numbers that are the same kind of numbers. So we need to do what we're asked to do. 6 minus 4 is positive 2. Over here we have nothing that we can combine. So now we're going to follow the algorithm where we take the use additive inverse to move numbers across to their like numbers on the opposite side of the equation. So additive inverse of positive 2, or adding 2, is subtracting or adding a -2. So we're going to subtract 2 from both sides, canceling that out. At the same time, let's go ahead and take our x using additive inverse, so minus 3x, canceling that out and simplifying. 4 minus 3 is 1x equals -6. If on the exam you're concerned you're not getting it right, maybe you see your answer there but you're just not sure, plug your answer in right here and right here. Use your calculator to check to see if both sides of the equation are equal. Alright, down here folks we have a couple of options for you. But what I like to do is clear the denominator so that we can make this problem look more like this problem. So what you do is you start off by finding the least common denominator. So well, first let's make everything have a denominator. Least common denominator of those three numbers is 21. So we're going to change all the numbers in the equation by multiplying everything by 21. So we're going to do 21 times 2y over 7 minus 21 times 4y over 3 equals 21 times 11. Because it's an equation, if we change one number, we have to change every number using the same operation and the same value. Now what we're going to do is we're going to cancel. 7 goes into 21 3 times. We're going to multiply to finally get our answer here, 6y. Nice, beautiful single term. Same thing here, the 3 is going to go into the 21 7 times. We're going to distribute the 7 or multiply. So that's going to be a -28y, and then we're going to multiply here. 21 times 11 is 200, and 31. Alright, now again, following the algorithm for solving an equation. Now that it's simple, we're going to combine like terms. We get -22y equals 231. And then we're going to divide. Opposite operation here, this is multiplication, so we're going to do multiplicative inverse. We're going to divide here, and we get y is equal to positive divided by -10.5. Again, all you got to do is plug the 10.5 here and here, multiply it out, and you'll find that it's the correct answer, so -10.5. Here's the next one here. Now this is the same process, however we do have this one issue of having an inequality. Remember that on an inequality you solve it exactly like you would an equation, except for one thing. If you have to divide a negative to move it from one side of the inequality to the other, you have to reverse the inequality. So if it was a greater than or equal to and you divide by a negative, you have to reverse it to a less than or equal to. And I believe this is going to happen here because I see that when I multiply this, I'm going to get a -6x. So -6x plus 18 when you multiply there, greater than or equal to 3. We're going to solve it. Draw on your barrier there. using opposite operations. Okay? You get negative 6x greater than or equal to negative 15. The last thing you're going to do is divide by that negative. But remember what I said, when you divide by a negative, the symbol must reverse. And then we also should reduce this because 3 goes into both of those. So we get 5 halves. And there you have your answer. All right. Number 4, you have exponent rules here, and you have, this is a power rule here. You're going to be multiplying this times itself 5 times. You could write it out 5 times, or you could use your shortcut of distributing a power to a power. So that's the shortcut, x to the 10th, y to the 15th. Very simple, better than multiplying it out 5 times. Now down here you'll notice that we don't have powers out here to distribute in here. Okay, so what we're going to do with this is we're going to regroup. We're also going to remember that, one moment, hang on just a second guys. Okay, so what I was about to tell you guys was this. Remember that you're going to be multiplying, and you have to multiply like numbers, so 5 and 2. So what I'm going to do is I'm going to regroup. So there's my 5 and my 2, so I'm done with those. And I'm going to regroup my x's, x to the negative 14 and x to the 56. And I'm going to regroup my y's, putting all my like terms, or all my like things together. But what I wanted to point out here is now I'm multiplying same base. Now let me make this more simple. If I had x squared times x, you guys would have no trouble telling me that that was x to the 3rd. Why? Because you're adding the exponents in your head. If I said x to the 5th times x, you would say x to the 6th because we add. So that's basically what's happening here. That's exactly what's happening here, in fact. We're going to multiply our lead numbers, constants. 5 times 2 is 10. Now we're going to add negative 14 plus 56, and that's positive 42. Here we are going to add again 34 plus negative 18, and that gives us, let me do the math real quick, and that was y to the 16th, and there you have your answer for that. So make yourself a note. When you're adding, when you're multiplying same base, you're supposed to add your exponents versus when you do power to a power, you multiply. All right, moving on. Here we have kind of the opposite of doing the powers. When we were doing powers like this, we would multiply, so we'd get x to the 12th. Now, roots are the opposites of powers, so what we're going to do instead is we're going to be dividing our roots, because our exponents here, because it's opposite of raising to a power. Okay, but my suggestion is we split this up and we simplify the square root of 44 by itself, and we simplify the square root of x to the 14th, and square root of y to the 19, and square root of z to the 31. Okay, this is my suggestion. So 44, we break that down to looking for our perfect square, and there it is. So 44 is 2 square root of 11. So we'll save that for later. Now, like I said, this is a square root. So what you're going to do is divide. Any whole answers come out from underneath the square root. Any remainders stay in. Well, 2 goes into 14 exactly 7 times with no remainder. So there is no longer an x in your square root. However, there are a lot of pairs of y's here, but because this is odd, I am going to have a remainder. So all you do is divide 19 by 2. That's going to give you 9. You're going to have a remainder of 1. So your 9 exponent can come out, but this 1 has to stay in. So this is going to, you don't have to write the 1 by the way, reduce down to that or simplify to that. Same thing here with your 2 into 31. So if you cut 31 in half, right, that's 15 with a remainder of 1. So 15 exponent come out and the 1 staying in. So this would be z to the 15 and then z to the 1. So what we're going to do now is we're going to put all of these together, starting with the 2 and then everything else that's outside our square root. So we have the 2 and x to the 7 and y to the 9 and z to the 15. Those are all done. Now what we're going to do is put our leftover square roots back in. So we have the square root of 11. There was no x. Square root of y to the first power, square root of z to the fifth power. The first power, sorry. And there we have our final answer. You guys got it? So when you're doing square roots or roots and exponents, divide. Okay? Alright, I got to do a little erasing here for you. Alright, so now we're moving on to our factoring steps. Alright, so remember when we factor, we're always trying to break our trinomials into two groups if possible. Always first look to see if they have anything in common. We don't have a common number and they don't all have x's. So the next thing we do is we try to break up our first term, our a term, and our c term. 2 and 1 is the only way to get 2. There's a couple ways to get 21, but let's just try a 3 and a 7. Now one of these has to be negative because this is negative. This is a negative 1. So if we multiply that, we get 6x. If we multiply that, we get 7x. We want negative 1, so we want that 7 to be negative. So there we have our pairs. We want to multiply these two. So we're going to put our x and our 2x in our front positions. Now remember, I want to multiply the 2x times the 3. So that's got to go in this outside box. And then we want to multiply the 1x times the negative 7. The way that you can remember that, if we have this organized like this, and we decide that these are our pairs, 6 and negative 7x, once you find your pairs, just cross circle, and so this would be your first pair, and then that would be your second pair. Double check it by multiplying it back together and seeing if you can come back to your original trinomial. Alright, so this is the same concept here, folks. However, we have a lot of terms here, trinomials and binomials, and so you're going to have to factor and try to get them all to be powers of 1. So first we're going to factor this, and nothing in common. So let's split the x in half. The only way to get 3 is 3 and 1, and when we multiply those, we get 3x and x. That makes 4x. So this is going to factor x plus 3 and x plus 1. Coming down here to the bottom, notice they have an x in common. Let's factor that out, leaving us with x squared minus 4. Now the alert here is that we still have an x squared. This is a binomial and these are perfect square subtractions. So remember that. That'll continue to factor to x minus 2, x plus 2. Why? Because when we do positive 2x and negative 2x, they cancel out. So we don't have anything in the middle. So that would be the final version of this bottom one. Here we have this one. All they have in common is an x. That leaves us with x plus 2. We don't have anything else to do. X's are to the first power. Down here, the x is already to the first power. So I'm going to rewrite it with its factored out versions. And then we're going to multiply. Actually, what we're going to do is cross simplify to make it a bit easier. Times x plus 2 over x plus 1. So first what you do is you try to cancel out vertically, but I don't see anything. These aren't in common and these aren't in common, so I start going crossways. Well, this x plus 1 and this x plus 1 cancel out, and this x cancel out, and this x plus 2 and this x plus 2 cancel out, leaving us with a numerator x plus 3 over x minus 2. Now I'm going to find a couple of you guys, that's the answer, but a couple of you are going to try to do that. That's a no-no. We do not try to simplify further. You don't get rid of part of a binomial. Like for example, if I said x was 10 and I plugged a 10 in here and a 10 in here, my top would be 13 and my bottom would be 8. I can't reduce that. They don't have anything in common. So don't try to continue to simplify things. It's the whole thing. You cannot simplify or cross out part of a binomial. Alright, here we have this problem here. You're asked to write the equation of this line in slope-intercept form. Well, remember what slope-intercept form is. Here it is. This right here is your slope, or your rise over your run, and this here is your y-intercept. So we write our y down and we write our x down and we fill in these two numbers. So first let's find our y-intercept. Here it is. It's -6. Now let's go look at our rise over our run. So we're going to count from here to here. This is up 1, 2, and running 1 space because 1 is 3 steps over. So that's a rise of up 2 and right 1. Up 2 and right 1. There's our slope. Final answer, y equals 2x minus 6. And we know it's a positive slope also because look, it's rising, guys. So just remember to count from point to point, intersection to intersection, rise over run. Okay? And there you have that one. Moving on. Here we have change this question to say this. I wanted you to change this just because the number that was here before was just so large, and it's cool to check that out, but I just want this to look a little bit more like what it's going to look like on the test. So it's saying a vertical line is passing through this point to -10. So on the test, basically what you guys could do is you just could draw yourself a little graph. You could graph it no problem to -10. So 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is right there. And it says it's a vertical line that passes through this point. So I'm going to go ahead and draw a vertical line passing through this point. And it's asking for the equation of this line. So a couple things you could do. You could just list a couple of points on the line if you want and graph. So this is 2, 0. This point's 2, 3. This point down here was 2, -10. What you should be realizing here is that the 2 is never changing, and the 2 is in the position of the x in our coordinate. The equation is x equals 2. Okay? It doesn't have a y-intercept, so it can't have a y in the equation. Remember, equations only have y and x if they're diagonal lines. Okay? If it's a horizontal line like this one would be y equals 3 because everywhere on this line y is 3. -1, 3, 1, 3, 2, 3, 5, 3, whatever. Okay? So if it doesn't have a y-intercept, shouldn't have a y in it. So x equals 2. Fastest way to do it is to list a couple points and then see what's unchanging. X is unchanging, so it always equals 2. Alright, here we have this one. Now this one's a little bit more of a stinker because we have to write the equation. We have this little segment here at -3, 7 and 3, 5. And what you have to do is write the equation of its perpendicular bisector. Well, perpendicular is all about slope. So let's go ahead and take a look at the slope really quick, because that's going to be part of our equation of our new line here is our slope. So this has a slope of down 2 and right 1, 2, 3, 4, 5, 6. So this one has a slope of -2, 6, which reduces down to -1/3. Now perpendicular slopes, if you recall, are opposite, positive and negative. So that one's negative, so this one's positive because we want it to rise and cross like this. So, and this one is rise 3, so I go up 3 and run 1 or down 3, and you can see that that's intersecting at a beautiful right angle. So make on your note card, perpendicular slopes are opposite reciprocals. Alright, so we already know that our slope for our new line is going to be 3. So y equals 3x. Now we just have to see the y-intercept. Now, before we do that, we do have to find the midpoint of this line. Couple ways you could do it. You could use the midpoint formula. So what you would do is midpoint is equal to, using your 3 and your -3, so -3 plus 3 over 2. And then you do your y's, and your y's are 7 plus 5 over 2. Okay? And then what you do is simplify. So this is 0 over 2, which is 0. So your midpoint's at 0. And this is 12 over 2, which is 6. So your midpoint is actually 0, 6, which works out so nicely because that is the y-intercept. So plus 6. There's the equation of your line. Perpendicular, okay, Bisect means it's hitting at the midpoint. That's what bisect means. Cuts it in half. So that would be at your midpoint. So this line would look exactly like that. Intersect. Okay. Moving on. Here we have this. What types of triangles are formed by the points? Holy mackerel. I think the best thing to do probably here, you could use your distance formula or you could use Pythagorean. What I'm going to do is I'm just going to make these points here. So 4, 2 is that point right there. 6, 1 is right there. And a -1 up 3 is right there. What I'm going to do is, this really almost doesn't look like a triangle, but it is one. So I'm going to go ahead and make really skinny lines so that we can see that it actually is a triangle. And we're going to connect these 3 points. So what you're trying to determine, folks, is what kind of triangle is this? Well, first of all, this is a very obtuse angle, and you can tell it's very obtuse. So we would say that triangle ABC is obtuse. We name triangles in 2 ways, by their angles and by the types of sides they have. Now, with the sides, you have to determine their lengths. So this is where I said maybe the Pythagorean theorem would be helpful. Here you have 1, here you have 2. So this would be a 1 squared plus 2 squared equals c squared. That's going to give you your hypotenuse. So that would be 1 plus 4, which is 5. Square root of 5 is the measure of this. So that's the square root of 5. Let me go fix that up. So the measure of this one is the square root of 5. And what you would do with this one is the same thing. Turn it into a right triangle. That's a 1 by 1, 2, 3, 4, 5. Okay? So that one would be a 1 squared plus a 5 squared equals your c squared, your hypotenuse. So 1 plus 25, or 26, equals c squared square root. So this one here is this one right here, and now I got to go erase my work so I can show you, is the square root of 26. And then the last one here you have is this one, making this a right triangle. So you have 2 and 1, 2, 3, 4, 5, 6, which is the one we found before. So it's 2 squared plus 6 squared equals c squared. You can already tell that this is going to be different. That's 40, right? So square root of 40. So all 3 of those are different lengths. That means that it's going to be scalene. So if I were to name triangle ABC, I would say it was a scalene obtuse triangle. Triangle DEF, same process here, folks. So I'm going to rearrange and cancel these things out. Let me make my eraser a bit bigger here. Clean this up. And I'm going to move my points. So I'll get my lines out of the way here. And I'm going to move my points. So this point, D, is at 6, 3. There it is. 6, 1, I already have graphed. And -1 up 3. So here's what I have here, folks. I have this triangle. And if you look at that, we have a nice right angle there. We don't even have to do anything special there. That is going to be a right triangle. We have a right angle there. So we know that it's a right triangle. Now we just have to determine if it is scalene isosceles or if it is equilateral. Well, that's got a length of 2. 1, 2, 3, 4, 5, 6, 7. That's got a length of 7. Obviously, the hypotenuse is going to be even longer. 4 plus 49. I'm just squaring these in my head. So that's square root of 53. So all different. So this is a right scalene. All right. The last one here is triangle GHJ. So same process as we had before. I'm going to go ahead and get rid of those. Oops, I erased the wrong line there. Let me put that back. It was right there. I'm going to make it fatter here real quick. Alright, sorry about that. Alright, so we're going to go move our points to where they go. So this one's -3, 0. That's right there. 0, -3. Alright, I just want the point there. Can I have the point? Let me unattach some of these things here. Okay, 0, -3, and 6, negative 3. 1, 2, 3, 4, 5, 6. All right, so here we have this triangle here, folks. And I'm going to connect them again. So we have, again, we have another obtuse triangle, so we didn't have any acutes. Now all we have to do is determine if it's scalene or if it's obtuse again. We know that because look at that angle, it's greater than 90 degrees right here. So we know it's obtuse. So again, it's the same process. 3, 3, so 9 and 9 is 18, so this is the square root of 3. Square root of 3 is going to be the square root of 18. Here we have this one, we can count 1, 2, 3, 4, 5, so that's 5. And then here we have this great big one, which is a 3 by 1, 2, 3, 4, 5, 6, 7, 8. I'm pretty sure 3 squared is 9, 8 squared is 64. This is going to be the square root of 73 and long. So another one that is scalene. So all three were scalene. This one was obtuse. This one was obtuse, and this one was right. Now the one thing we have to remember is that on the test you might quite possibly get a point that's here and a point that's here and then another point that's right here. And you might have to you do a little math to determine if that's a right triangle or if it's acute or obtuse. So remember what you do is you find the slope of both. This has got a negative slope, okay? It's going up 2, but it's going left 2. So that has a slope of negative 2. Well, it's a negative 2 over 2, which is a negative 1. It has a slope of negative 1. Whereas this one, if we count, has a rise of 1, 2, 3, 4, 5, and a run of 1, 1, 2, 3, 4. So that has a rise of 5 and a run of 4. This is not the opposite reciprocal. They're not perpendicular because they're not opposite reciprocal. So this is not a right angle. So that's the kind of thing that you got to be careful about. When it looks like a right angle, you have to prove it by finding out if the slopes are perpendicular. All right? Let's do 3 more problems today, and then, or 4 more. We'll go to number 17, and then we'll quit, and we'll do the other half tomorrow. This one here we have to graph. So we're graphing an inequality. It's a lot like graphing a line. First, what we need to do is take and put this in a slope-intercept form. So we're going to solve it for y. Remember again, if we divide by this negative, we're going to reverse the symbol. So moving the 3x over to here, negative 9y greater than or equal to negative 3x plus 27. Now the reason I'm putting the x in front is because I am trying to put it in slope-intercept form so that it'll graph. Dividing by the negative 9 here. Simplifying. I did divide by a negative, so I'm going to be doing less than or equal to, reducing this down to 1/3 x, reducing this down to negative 3. Graphing this line. So negative 3 is my y-intercept, and my slope is positive. This is my slope. Rise 1 and run 3. So I'm going to rise 1 and run 3. I think we'll reverse it down and left 3. And now I have to determine whether or not I'm going to draw a solid line or a dotted line when I do inequalities. Because of the equal sign, I'm going to go ahead and do a solid line. So I'm going to graph right through that point, draw my line right there. Now the thing about inequalities is once you've graphed your line, what you've done is you've graphed the boundary, and you've separated your graph into 2 regions, and you have to choose the side of the graph that contains the answers. It might be all of these points over here might make this side greater than this side, or all of these points down here when we plug them up might make this side less than this side. So now we have to go do a test point. Since 0, 0 is not on our line, we can test it by plugging it in. So we plug it into your original equation here. So 3 minus 0, or 3 times 0 minus 9 times 0 greater than or equal to 27. Well, I'm sorry, but 0 is not greater than 27. So this is false, which means that 0, 0 is not part of my answer set. So I would shade the other side of my line. So I would shade on this side. Okay? So first put it in slope-intercept form. Y equals mx plus b. Graph your line, your boundary line. If it's greater than or less than, you'll graph a dotted line. greater than or equal to, less than or equal to, graphing the solid line, saying you want to include the points on the line, part of the answer. Then once you're done, pick a test point, plug it in. Test point cannot be on your line. If it's true, shade the side of the line containing your test point. If it's false, shade the other side. Alright, here we go. We're going to solve some more equations, but here we have a square root equation. So the first thing we got to do is get the square root alone. So we're going to move this one, and we're left with square root of 4x plus 1 equals 9. Alright, so now we're stuck in the situation where we have this square root, and this x is inside here, and this 1 is inside here, and we got to get them out of there so we can do math. So to get rid of square roots, remember, we square. Now we are powering up, which means we have to check our solution. Okay? We're powering up. So that cancels out to 4x plus 1 equals 81. And now we've got what we need. We're going to move that to the other side. I'm going to take this up. So 4x is equal to 80. Divide by 4. We get x equals 20. Now all we got to do is go and check it. Okay? X is 20. So we're going to plug it in. Negative 1 plus square root of 4 times 20, which is 80 plus 1, equals 8. Alright, so this is 81, right? 81. Square root of 81 is 9. And hey, negative 1 plus 9 is 8, so check. There's our solution. Okay? Alright, now the next one is a little bit more challenging. Remember that there are two kinds of numbers that can go inside a square root. And that, I mean an absolute value, pardon me. That means we can put negatives or positives in here. So what you have to do to solve these, I'm going to rearrange it and put my absolute value, they're going to switch sides, okay? So here we go. Square absolute value, I got to stop saying that. Absolute value, 5x minus 8 minus 6 is equal to negative 4. Alright, before we solve this absolute value equation, we have to isolate the absolute value. So if you're on your note card writing the absolute value equation down, make sure you write before solving, make sure that the absolute value is isolated on one side of the equation. So we're going to move the 6 to the other side so that we have absolute value alone. And the other thing to check is that this answer over here is positive or 0, because absolute values cannot equal negative numbers. The numbers inside can be negative, but not outside here on this side. Alright, now that we're solving this, what we want to do is solve it twice, because there's two numbers. I can put inside here a 2, absolute value of 2 equals 2, or I can put a negative 2 inside here. Absolute value of negative 2 is also 2. So when I go to solve this, the first time I solve it, I drop the absolute value. And the second time I solve it, I set what's in the absolute value equal to the opposite. So you do both of them, because the number inside the absolute value can be positive 2 or negative 2 and equal 2. So drawing our boundaries, moving the 8, we get 5x equals 10. Divide the 5, x equals 2. Same process, add the 8, add the 8. 5x equals 6, divide the 5, divide the 5, x equals 6 fifths. Okay? Solve it twice. You want to check, you can plug it in. So let's say I plug in the 2. So we do 5 times 2 minus 8 minus 6 equals negative 4. Let's see if this is true. This is 10. 10 minus 8 is 2. Absolute value of 2 is 2. 2 minus 6 is negative 4. Check. So plugging in the 2 worked. Now what I'm going to do is I'm going to go plug in the 6 fifths. So let me do that. So I'm going to do 5 times 6 fifths, sorry, it's positive 6 fifths, minus 8 minus 6 equals negative 4. So these are going to cancel out, alright? Leaving me with 6 minus 8. That's negative 2. Minus 6 equals negative 4. Absolute value of negative 2 is 2. 2 minus 6 equals negative 4. Check, it worked again. So they both work. Remember that absolute values almost always have two answers. Okay? So we have two more problems to do. Here we have a tangent Alright, so here we have tangent, a tangent theta. Now tangent, remember, is opposite over adjacent. So what I'm going to do is I'm going to go ahead and I'm going to label the opposite side 88 and the adjacent side 105. And there should be a right angle there. I forgot to put it in. Alright, now that's going to help us do some math. Now we're supposed to find cosine of theta, but cosine is opposite over, no, it's adjacent over hypotenuse. But folks, I don't have the hypotenuse. Couple things we could do. We could use a reduced triangle theorem to help us solve this, or we can just use your Pythagorean theorem here to find your hypotenuse, because we need that. So let me grab my calculator real quick. Hang on. Alright, so here we get 7744 plus 105 squared is 11025 equals c squared. I'm going to add those two together. 7744. You know what, guys? Give me a second. This calculator's not working. Okay, sorry about that. Here we have this. So it's 18,769 equals c squared, and then of course we're going to square root that. So let me get that in there, 18,769, and we get exactly 137, which means that this was a triangle family. It's a 5, 12, 13 is what it is. But now we have these two numbers. So the adjacent is 105 and your hypotenuse is 137. So cosine of theta is 105 over 137. Now, we weren't asked to find the angle, but remember, if you want to find the angle, use your cosine inverse or your tangent inverse. Alright, moving on. We got one more to do for today. Alright, here we have a problem. A ladder leaning against a house is 13 feet long. So here's our ladder, here's our little house over here, here's our house. Okay, it says, what is the distance from the base of the ladder to the house? So we want to know, what's this distance here? The angle of elevation is 39 degrees. So I'm going to put my little degrees there. Alright, so I'm looking at my angle, that's where I'm focused, and this here is my adjacent, and there is my hypotenuse. So we're going to be using cosine. So cosine of 39 is equal to adjacent over hypotenuse. We're going to cross multiply here, x equals, I'm going to grab my calculator, cosine of 39 times 13, and we get 3.46. So we're just going to round it to a 3.5. So it's about 3.5 feet away from the house. Okay, and that's it for today. Tomorrow I'll make the other 17 or 18 questions. Have a good night, everyone.